So in the previous video, we compared a more complex model in the crossed orderings pattern analysis to a simpler model. And recall that for the more complex model, the PCC was 73.20. That is the model that included the gender ordering. And then the simpler model, the PCC, was 71.40. So that's a difference of 1.80. So almost 2% difference or increase in the PCC. Now, we can run a randomization test in an attempt to rule out physical chance as an explanation for that approximate 2% increase. Now to do so, let's go back to the analysis. So I'll select analyses here and pattern analysis and crossed orderings. So we have the complex pattern already set up here. So there it is for the males, there it is for the females. I'm just going to run the analysis again, but now I'm going to turn on the randomization test. And I need to randomize by the deep structure. So make sure that that is selected for this type of pattern for the males in particular. When you have these simpler patterns, you need to randomize by the deep structures often, or else your PCC is going to wind up being 1. So we'll select deep structures there, and we're going to save the randomization results. So I'll select OK, and it will iterate through. Also get a note here that a new data set has been created. So I go to the data edit window, and there it is. So these are the randomization results. I'm going to name them complex for the more complex model. And now I'm going to go back to the analysis again. So analyses, pattern analysis, and cross orderings. I need to go to the data set. There it is. And now I want to take gender out, and then I'm going to now have to redefine my simple pattern. So notice now there are no difference between males and females here. This is the simple pattern. We've gotten rid of the gender ordering. So I'll select OK. Again, the randomization test. I'm going to save them. Randomize by deep structures. Select OK. Iterates through. There's the 71.40% again, and again I get a note about a new data set, and there it is. And so we can relabel it randomization results simple. Okay, now what I want to do is copy the PCCs from one randomization test into the data set of the other randomization test. It's arbitrary how I do the copying here. I'll just go ahead and copy this simple into the complex. So I'll select edit and copy delete orderings, the PCC, and I need to copy that into the complex. Select OK. And there we have it. So now we're in the complex data set here, the randomized PCCs, and here are the two sets of PCCs. Now if I want, I could label these as well. It's really not necessary, but we could call this PCC complex, and then we copied in the simple PCCs, or the PCCs from the simple model. Again, these are randomized PCCs. Okay, and select OK there. And now I need to create a new ordering, where I'm just going to take the difference between these two sets of randomized PCCs. So I'll select compute, and then compute new ordering, and I'll take the complex, and I'm going to subtract that, or subtract the simple rather, from the complex, and we'll just call this PCC diff. Select OK. And there we have it. So now let's go ahead and sort these and see what we've got. So I'll sort the cases, or the observations rather, PCC diff. Okay, and we can see the minimum value was negative 11.80, and then scroll down 1,000 differences here. The maximum value was 10.80. So we are finding differences between the randomized PCCs that are greater than or equal to that approximate 2% or 1.8 increase that we saw from the simple to the more complex model. So now to turn that into a chance value, we need to find out the proportion of values that meet or exceed that 1.80 difference. So let's do that by selecting the Define Orderings window button here. And here are the diffs. We can take a look at the distribution. And we can scroll down. It's kind of normal looking distribution. That's not really all that important to us though. And I'm going to scroll down here, and I'm going to find that 1.80 because I'm going to combine orderings here, or units of observation I should say, for these differences. And I'll scroll down. There's that maximum value. And so now we have this unit of observation here that goes from 1.80 to 10. I'll update it, and there you can see it. So there are 260 of these differences between the randomized PCCs that are equal to or greater than the 1.80. So if you turn this into a chance value, we have 1,000 cases here, so 260 out of 1,000, that's 0.260. So not an impressively low chance value here. So in this case, under conditions of physical chance, finding a difference in the PCCs, the randomized PCCs, of 1.80 or greater is not all that unusual. So we would take this into account and or into consideration when we debate whether we want to take that 1.80 increase as being important, either clinically or theoretically.